let's get into the big topic of open source, something that we actually say at Red Hat.
We have a
This is so
we
awesome.
are an open culture that believes in the importance of
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Administrator live stream. And I hear something coming from my computer, so I'm going to have to mute it real quick here. I don't know where that came from, but hopefully nobody else heard something playing in the background. There isn't an echo of us here, Johnny.
I don't hear it if you hear it. Like it's totally clear to me.
Good. I'm glad that it didn't impact us at all. So, well, happy Wednesday. It's another great Red Hat day here. So unfortunately here in Raleigh, it is gray and disgusting. And like if I look more washed out than normal, it's because most of the light in my room is coming from the monitor in front of me instead of from the windows.
Yeah, it's sunny. It's like in the low 40s here, and it's supposed to get to a balmy 66 today. So it's going to be a cool one here.
Yeah, well, anything below 70 is cool in Texas, right?
That's pretty much winter,
Yeah. Well, hello to everyone who is joining us. Hello, Khalid. Thank you for the welcome. Our Hope 9 as well. So today, this week, we're going to be talking about a couple of OpenShift 4.10 topics. So these are things, we briefly mentioned them last week, and they were talked about during the What's New session by the product management team. But we wanted to do a little bit more of a deep dive on these because they can be a little bit more complex. So I've done some testing. I've done some things inside of my lab. Hopefully we can illustrate some of these points. That being said, I will, in full disclosure, say that Andrew is not a networking expert. I've been many things in my life. A network administrator is not one of them. I have kind of an architect's level understanding of, like deep down networking concepts. So don't let that stop you from asking any hard questions, because I would very much love to go back to engineering and the super smart folks that are working on these things and take those questions and maybe even bring them onto the live stream in the future so that way we can talk about all that stuff. So if you're curious about, if you're interested in, today we're going to be focusing on NMState. So NMState is a desired state engine configurator. That's the word I'm going to use for Linux networking, and in particular, we use it with CoreOS and OpenShift. And we'll also be talking about MetalLB, in particular with OpenShift 4.10. MetalLB adds an L3 mode, or layer 3, which means that it's really we're working with BGP in order to do that load balancing. So it's going to be an interesting day, and we've got a number of other topics that we can talk about during the top of mind section. So Johnny and I were chatting about that beforehand. Of we're gonna need to be careful to not eat up like an entire show with. So.
Oh man, yeah, for sure.
All right. Well, so my normal introduction here, right? This is one of the office hours live streams here on Red Hat Live Streaming, which means that we are here for you, for our audience. Anything that is on your mind, any questions that you have about anything OpenShift related, we will do our best to answer those questions. So please don't hesitate to submit those. So whatever platform you're on, use whatever chat window you have, and we will do our best to answer those. However, sometimes we don't know the answer. I'll say a lot of times we don't know the answer, in which case we take that back. We go and find the SMEs, whether it's product management, whether it's engineering, whether it's anybody else inside of Red Hat, and we'll get those answers and publish them either through the blog posts or here on the live stream itself, as the case may be. G. Kumar, when is OpenShift 4.10 GA? Soon. I will say that. So if everything goes according to plan, very soon. I always tell people, internally at Red Hat, it's folks can find specific dates that engineering publishes. I always tell folks that those dates are subject to change at any moment in time. Like literally at any point in time, the QA process can find a blocking bug that'll push out a release date by anywhere from a day to a month, and it has happened before. So, assuming no major issues are found, we should see 4.10 drop soon. So yeah, thank you for asking that, and Karate Chop, thank you for your very kind words. We appreciate it. Although Johnny and I are just sort of the we're the tip of the proverbial iceberg, if you will, right? We're the faces that you see. I'm so sorry for that. But really,
Very sorry.
there's an organization of thousands of people behind us that help with all of this. Whether it's our individual teams, which my team or extended team has something like 30 folks on it now, all the way back through product management, which is another 50 or 70 folks, and engineering, which is hundreds and hundreds of folks, right? It's not just us. And of course, Stephanie's here to help us as well with all the amazing things that she does. I don't think I mentioned her last week, but she's a tremendous help.
She's the one.
Yeah. So yeah, anytime you see on whatever platform you're on, if you see like OpenShift or Red Hat OpenShift responding, that's Stephanie in the background. She's keeping us honest and posting links and all that other stuff, keeping us focused, if you will.
That's right.
What is it? Adult onset ADHD. Yeah,
that's right. Yeah.
Our Hope 9 caveat for non-US viewers this weekend is, thank you. That is actually one of the notes that I had to talk about today. And that, so yes, to our Hope 9 point, our Hope 9's point, daylight savings time takes effect this weekend here in the US. So what that means is that we will spring forward 1 hour. So for those of us in Europe, we will be 1 hour earlier in the day for you. So yeah, we always go to 11 a.m. Eastern in whatever time zone we happen to be in, or that happens to be. So like Johnny's in Central Time, for example.
Mm-hmm.
Karate Chop, if time permits at the end, I would like to hear about my lab setup. So I'll be showing a little bit of that today. So I set up most of the stuff here in my lab, either nested or well, actually all of it's nested today. So I can talk a little bit about that. My lab is pretty small and pretty humble and usually a jumbled mess of things. So
as it should be.
Yeah, as any lab is. All right. So just, please, any comments, any you have, drop them in chat. Restream puts them all across everywhere. So wherever it is that you're at, we will see those. We will do our best to respond to those and get you answers to that. So let's talk about our top of mind topics. So the first thing that I want to talk about here is something that we've talked about a couple of times with the deep dive. So we've done like the disconnected deep dive. We've done a couple of other topics around like creating, managing, updating disconnected clusters. And in the last week or so, I've had or seen a number of folks, probably 4 or 5 different questions, either in chat or email and various other places, asking about how do I convert a disconnected cluster back to connected, or how do I disconnect a connected cluster? So if we look in the documentation here, I'm going to share my window with the documentation. There we go. So if we look in the docs here, we have this process, which describes exactly what you need to do in order to do that. Actually, this one is converting connected to disconnected. So the short version is this mimics exactly the disconnected install process, and that you create a mirror cluster, a mirror registry with all of the images that you need and all that other stuff. And then effectively you go through and so mirroring the images here, I'm scrolling down, configuring the cluster for the mirrored image. So the first thing it's going to do here is have you set the global pull secret for any policies that you need, or for any credentials rather that you need for your mirror registry. Add the certificates for that mirrored registry, and then create an image content source policy that redirects everything over to where you need to be. So if you've ever done the disconnected or mirrored install, right, this image content source policy is exactly the same thing. And in fact, one of the commands that's further up above for mirroring the images, it spits out the ICSP that you need to do that. So I bring this up because, in particular, and I scrolled right on past it on purpose, you'll notice that this process is tech preview. So the process of converting is not a supported process. It's technically possible, and I've done this a number of times, but it is not one that the support team is able to help. So if you're trying to, disconnect a cluster and something's not working, effectively the support team doesn't, they can't help with that. So if we take this process and we reverse it, that is how we connect a disconnected cluster. So usually the biggest thing is updating your pull secret. So if you deployed disconnected and used just a private pull secret without your Red Hat pull secret, so update the pull secret and then remove the image content source policy. And then that'll point everything back at the Red Hat's registries, and it should behave as normal. The only other thing that I think is here, and I don't see it on this list, is if you have changed the update server. So let me switch over to this tab. So here in cluster settings, when it looks to where to pull these updates from, you can actually update that. So you can change it to be, and I've had several folks ask, even for connected clusters, can I point that at something that's not valid so that I can prevent some, any random administrator from going in and just applying updates? I can control when it sees an update available. Upgrade path. Yep. Thank you. If you've changed that to point at, say, the update service, the disconnected update service, you would just want to change that back to the default, pointing at the Red Hat hosted update service. Okay, so that covers that one. If there's any questions on that, I know we talk about disconnected fairly frequently. I'll say that this one is near and dear to my heart because, again, I do a lot of cluster deploys, and I found that it expedites things pretty significantly to have it locally mirrored instead of pulling across the internet. So Johnny, let's talk about security for a moment. So there was a CVE that was released earlier this week, right? I think it's lovingly referred to as dirty pipe. I use that facetiously.
Yes.
Yeah. So I'll open the link here that we have for the CVE, but I'll let you talk about it because I only have ancillary familiarity.
Okay. Yeah. And I mean, I might have just a touch more than that, but yeah, essentially the dirty pipe exploit, it's named after so we had Dirty Cow a couple years ago, which was another kernel level exploit, and I think it's either the same group that found the bug, and that's why it's named Dirty Pipe. It's just that's where the name kind of lineage comes from. But essentially, the way it affects the RHEL 8 kernel, the RHEL 8 real-time kernel, and the Red Hat for virtualization. I say it affects, that's the product that it affects, but it doesn't actually affect it because in RHEL 8, the flag that's being used for the exploit is actually not part of the RHEL kernel. But there is another underlying flag that could be used as an exploit that it hasn't been completely vetted out, like that it can or cannot be used, and so that's why it's still an issue. So right now it's affecting products, but it's not really affecting anything that you might have in your system. Anything older than like RHEL 7, RHEL 6, something with like an older 4. Kernel or even a 3. Kernel, it's unaffected. It's really going to be anything with the newer kernel base and even in like the 5. Kernel range. Yeah,
and I seem to recall I should do some more research on this. I thought I recall something about how it's affected, but no, thank you, Siri. I don't know why you're talking to me. I said that was strange. It's what is it? It's affected but not vulnerable or something with
right. Yep. So if you scroll up a little bit and you just look in that right there, so you can see that that's the flag that gets sent. So what essentially happens is they're overloading a pipe. This flag into a pipe. So they're just putting a lot of data in it, and that's how they're able to take over. So this isn't, it's part of our kernel base, but it doesn't actually affect anything that we have going. Okay. So that last line there, where they're talking about there's another flag that could be used, they're still investigating whether or not, what the attack vector is on that, if there is one.
Got it.
So that's probably why it's still like a thing for us.
Okay. So short term, it sounds like we should keep an eye on the CVE page, keep an eye out for any errata for the fix, but it shouldn't be cause for significant alarm. I don't want to undermine or understate the severity of the issue, but just that RHEL 8 with the known vulnerability or known vulnerability is affected but not vulnerable.
Our Hope 9, yeah, it not necessarily. I mean, it would essentially local access to the node, yeah.
Okay. Always learning something new.
Yeah. So I was trying to remember where like so the dirty pipe name, it kind of stuck out to me, right? And I was like, this is so weird. And yeah, so I think it's either the same person or the same group of researchers found it that found dirty cow. So that's where the name's kind of coming from. So it's actually pretty cool.
Yeah.
Um,
So I just clicked on the cm4all.com link here. It's similar to dirty cow, but easier to exploit. That's reassuring. And I saw this one. This one was on Slashdot as well. Slashdot was talking about how it's one of the more significant Linux kernel vulnerabilities in quite some time.
Mm-hmm.
So, okay. So as always, I always try and remind folks that with OpenShift and these CVEs, more than likely we'll only see RHEL 8 listed here. So CoreOS does not explicitly get called out. And the reason for that is because Red Hat Enterprise Linux CoreOS is not a distinct product or offering from Red Hat. It is only available through OpenShift. So we may see OpenShift 4 get added to this list. I don't know how they do all of that in behind the scenes. I know after the last one of these, I had pinged the security team, and there's a bunch of stuff in the backend systems that needs to happen so that they can track CoreOS errata separately from RHEL errata. So that's blah, blah, blah. It's beyond my understanding. So I would say for now, if you have questions, reach out to your account team. You can reach out to me and Johnny. We'll do our best to connect you with any resources that we have if you have concerns. But yeah, use the CVE here as sort of your starting point. There's should also be a RHEL security, Red Hat security bulletin, RHSB.
Mm-hmm.
So YNS never understood how MetalLB layer 2 works. We can talk about that. So yeah, we'll talk about that from in a minute, even though I've only staged how to do it with L3 with BGP, but we can still talk about how it does with layer 2. What else do we have? So let's talk about something that Johnny, you and I, we both immediately launched into this one when we were chatting about it earlier. And this is the one I was talking about where we could eat up a whole show.
Oh yeah.
Talking about cluster architecture. So in particular, I've been working with a partner and we're talking about what happens or how should you architect your OpenShift deployment if you have a small hypervisor cluster. So think I'm deploying to, maybe 3 hypervisor nodes or 4 hypervisor nodes. How should I architect my OpenShift cluster in order to accommodate that? So first, I'll address 2 nodes and why I skipped over that one. So 2 nodes does not have, much like having a cluster spread across 2 sites, does not have meaningful high availability improvement for OpenShift. The reason for that is because OpenShift has a 3-node quorum with etcd. So you're always going to have one node that has an imbalance. And if you lose that one node, right, that one node is a single point of failure. So I'm going to kind of skip over 2 nodes and assume that we always want it to have a minimum, right? The hypervisor cluster to have a minimum of 3 nodes. So that way we can have anti-affinity rules. We can keep our control plane nodes onto separate nodes for full availability, full resiliency in the event of a single node failure. So what are some of the impacts? What are some of the considerations? What are some of the thoughts that we should have as OpenShift administrators when we're knowingly deploying into a relatively small hypervisor cluster? So in my opinion, there's a couple of things that we need to take into account at the infrastructure node concept layer. So think, the router or ingress controller rather, and all of the other services that are associated with that. So in general, I've always suggested to folks that infra nodes are a good idea because you're taking workload off of your compute nodes and putting them onto nodes that you don't have to entitle. So it's more cores that you're paying for that are devoted to your actual workload. But we want to have kind of a minimum of 2 infra nodes. And the reason for that is ingress controller availability. Right? So the ingress controller will always have at least 2 instances. You can scale it down to 1. But of course, that means that if that node is lost, then you have lost access to all of your applications. So I would say a minimum of 2 infrastructure nodes. It may make sense, again, 3 or 4 hypervisor nodes, to have it match the number of hypervisor nodes that you have. it gives some availability, some rationale to being able to move those pods or recover those pods in the event of failure. And I think it also ties into the next section, which is compute nodes. So Johnny, I'll pause there. Any thoughts?
Yeah, so I mean, if you do anything like cluster logging, like you'll understand right away why you want to use infrastructure nodes. I mean, cluster logging can eat up a considerable, very considerable amount of resources on your application nodes, and so you'll want to use them for nodes. And then the other thing with it is, like, I think you made a good point about it not being entitled, and instead of paying for like a subscription and cloud cost, right now that's what you're really only paying for. You're paying for cloud cost. And it's just it's a good idea. It's easy to implement, and it's worth the trouble.
Trouble. And logging has, I think, 3 Elasticsearch instances. So it's another one of those where you'd want to have 3 infra nodes if you deploy the logging operator or the logging service. RHOP 9. Exactly. You and I think I started saying that at the same moment you sent that. So great minds think alike, right? So let's talk about compute nodes. So this is where things get interesting and a little more opinionated. So my initial thought around this was, one with, let's say 3 or 4 nodes. I'm going to use that interchangeably. I'm just going to say, a small number of hypervisors. Should we have 1 compute node per hypervisor node? So I've got 4 compute nodes, and maybe they start off as, 10% of the physical resources. So this kind of makes sense, right? In that I can evenly distribute my compute nodes across the physical resources that are available. Christian, it is not out yet. So I can evenly distribute my resources, my virtual resources across my physical resources. So that way I know when OpenShift schedules a pod to a node, it's not contending with other things that are on there. And that last point is kind of leading into, so where do we go from there? So what happens when I need to, scale up my cluster? I need more resources in OpenShift. Do I deploy, more compute nodes? So maybe instead of, 4, 8 CPU, 32 gigabyte of RAM or 64 gigabyte of RAM, virtual machines for my compute nodes, maybe I now have 8 of those, 2 per worker node or per hypervisor node. So there can be positives and negatives to that. I think that is particularly useful if you're encountering any pod count limitations on your worker nodes. But the issue becomes now I'm paying for, I'm using those kind of core OS without meaning to be redundant there. I'm using those things twice, right? If I have the logging service deployed, right, I've got 2 instances of FluentD forwarding logs over instead of 1. I've got 2 instances of CoreOS that need to be rebooted and all of that other stuff. So it makes it so that it's a little bit less efficient. The alternative is, will I vertically scale my compute nodes? So I've got 4 hypervisor nodes. I've got 4 compute nodes. Those compute nodes, they vertically scale until I basically encounter a pod count limitation, right? And then I can do things like add additional compute nodes to scale up my pod count. So, okay, what happens if I lose a node at that point? And in particular, what happens if those compute nodes, those OpenShift compute nodes, are a substantial amount of the physical resources, right? I'm doing this vertical scaling thing. Now each one of my OpenShift compute nodes is, 30, 40% of the physical resources. And one of those hypervisor nodes fails. Now I'm trying to fit 2 of those, potentially 2 of those, onto a single node, right? Letting the hypervisor recover my lost compute node. Is that a good idea? Maybe, maybe not. Now if I lose another node, I've now, OpenShift would technically still be running because theoretically in a 4-node cluster, I've only lost 1 etcd VM. So the control plane would still be running, but my compute capacity physically is reduced by 50%, right? 2 nodes failed in a 4-node cluster. If OpenShift, or if the hypervisor then restarts all of OpenShift's compute nodes onto the surviving hypervisor nodes, it doesn't know that capacity is lost. So we could end up in a race condition where OpenShift is trying to scale up a bunch of pods or add a bunch of pods into those, nodes that have just recovered, which is then leading us to do, the hypervisor to be even more overworked because it's also probably trying to recover a bunch of other stuff. So, anyways, where I'm going with all of this is, maybe we should consider in that instance not using virtual machine high availability. Right? Let those resources fail inside of the OpenShift cluster, and let the OpenShift scheduler make the right decisions about how to recover the workload. So if I go from 4 compute nodes down to 3 compute nodes or 2 compute nodes, we theoretically we should have defined things like pod priorities and resource requests and limits and all those other things to let the OpenShift scheduler recover things in the right order to get the right applications up and running again and keep everything functional. So thank you, Christian. Your beer money is in the mail. I appreciate you agreeing with me. In a larger hypervisor cluster, if we're talking, maybe 8, 12, 16, 32 nodes, maybe that doesn't make sense, right? Because there is enough excess capacity in that hypervisor cluster as a whole to, recover our compute nodes, our OpenShift compute nodes inside of there. So anyways, architecture thoughts for the day. Johnny, I know you've been chatting in there, so I don't know if you have anything to add to that.
No, I think you make a bunch of good points. And like I was telling you in the pre-show, right? Like I'd never even considered about scaling out and like the even distribution of the workload, right? It's always just been scale up to meet the demand. And, I probably should have thought about like that distribution, but it just never did, especially like when you're in cloud, you're just like, oh, just scale, keep going.
Yeah. Yeah. On a hyperscaler, yeah, it makes perfect sense. Keep scale out horizontally all day long.
World's your oyster, baby.
Yeah. But on-prem, and especially again in those small hypervisor count deployments, it takes a little more thought, I think, and identifying which scenarios you want to protect yourself from. For years, Johnny, you and I were both VMware administrators, once upon a time, and for years it was always everything gets VMware HA turned on all of the time with no exceptions. Maybe we'll set a restart priority type of thing so that way we get, the critical stuff back up first. But when there's a whole secondary scheduler, Kubernetes, OpenShift involved in that recovery, it's something that needs to be accounted for, when we do those recovery plans. So, anybody, if you have any thoughts, comments in chat, please don't be afraid to post those in there. We'll certainly continue that discussion as needed. You're also welcome to reach out on social media. I see Johnny's information there up on the screen now, JRockTX1 on social media, or Johnny, no H, at redhat.com. And you can also reach out to me, andrew.sullivan@redhat.com, or Practical Andrew on Twitter. And we're both also on Reddit as well. So if you look for any of the Reddits, Johnny's been pretty good about putting Reddit posts up about each one of our live streams. So you can, of course, respond in the comments there, and we're happy to have a conversation. All right. In the interest of time, we've got one more very quick top of mind topic, and that is topics for the future. So just a quick recap. Last week, I worked up our schedule. We were supposed to have the Microshift guys on. They were very, very generous in allowing us to reschedule. So we will have, in 2 weeks' time, we will be talking about Microshift. So that would be the 23rd, March 23rd. Next week, we will be joined by Ortwin Schneider to talk about the service mesh. So that's kind of the next 2 weeks coming up. I think the What's Next presentation, so the roadmap presentation, is coming up in early April. So whatever day that happens, it overlaps with our show. So we won't be on this stream, will not be airing, but Johnny and I will be here to help answer questions and help funnel things over to the PM team, etc. So keep an eye out for that. As always, if you are interested in all that, please don't be afraid to subscribe on whatever platform you happen to be on so you can be notified. I also always encourage folks to go check out red.ht/live streaming. That takes you to our landing page, and it has the embedded Google Calendar that has all of the streams, including we update those when we do things like if we have to cancel or anything like that. So it can be useful. I usually copy the ones that I know I want to attend onto my personal calendar, so I get reminders. All right, so let's talk about some networking. When you set up an HA proxy on helper node for OpenShift installation, is that the exact one that is in later steps transferred to the control plane, or is the control plane's instance of it created separately? So helper node and the HA proxy instance that it deploys there, no need to apologize there, or ORPID. Apologies if I butcher anybody's name. And hello, Mike. Nice of you to join us. So the HA proxy instance that's deployed to helper node is an external load balancer that's used for the API-int and star.apps ingress endpoints. So in a UPI or a non-integrated installation, we need that external load balancer to send traffic from outside. So when you browse to the console or when you access the API from your terminal, to send that over to the right host inside of the cluster. So the HA proxy instance that is deployed as a part of the ingress controller is going to be different. So the ingress controller is going to accept that traffic coming from outside, so maybe that external load balancer, and identify which pods inside the cluster need to receive that. So when you create your service or whatever that happens to be, it's the one that determines how to get to that. So one thing to note is that if you're doing IPI or an assisted installer install, it will deploy a load balancer. If you can see me, I'm using air quotes here. So that it isn't a real load balancer. What it is a virtual IP address that's managed by KeepAliveD. So when I create the ingress VIP, when I assign it that IP address, KeepAliveD on the worker nodes, on the compute nodes, will manage that virtual IP address and ensure that it is always on a compute node that has an ingress controller. So that way that traffic coming from outside lands on one of those nodes, right? It is directed to one of those nodes, and then HA proxy for the ingress controller manages that directly. So let me catch up on chat here real quick. And then hopefully that answered your question. If not, or if that's not clear, just please don't hesitate to ask clarifying questions. So we'll get to that. Johnny, I see you're looking up some kind of ACS here, or KCS rather.
Yeah, so Fahad was asking and I apologize if I butchered your name there. He was asking about what services can go on the infrastructure nodes, and I'm trying. There's a KCS that actually lists them out. I just can't find it right now, but I'm going to keep digging. Essentially, it's Quay, the OpenShift registry.
Guide.
What's that?
It's in the subscription guide.
Oh, okay, awesome. And then so I'll find that and post that. But yeah, it's Quay, ACS, ACM. Things like Red Hat Service Mesh are going to be because it's an application workload, or it's at the application workload level. That's why it would typically not go on an infra node, and it should go on your app nodes.
Yeah, if we can share my screen here. So I posted the link into chat on Twitch. So the subscription guide, as we scroll all the way down here, and I'm silently cursing Christian's name because he handed this thing off to me. So we have this infrastructure nodes section down here, and it tells you about all the stuff that is considered infrastructure workload, including down here. It's not just see everything up here is either OpenShift or Red Hat. It's not just those things. So for example, if you are using Turbonomic or something like that, and they have a monitoring agent that gets deployed, that doesn't invalidate its status as an infra node. If you're deploying CNI CSI drivers and the stuff that they use, that doesn't invalidate as an infrastructure node. It's when you deploy your applications, right, stuff like that, to it, that it invalidates that what we call customer workload or customer application workload, that it invalidates the infra node status. So hopefully that helps with that.
No, that's perfect. Thank you. That's exactly what I was looking for.
Yeah, shakes fist to me. That's right, Christian. This this subscription guide is the user-friendly version of the official legalese Red Hat subscription guide. So we basically regularly go through and try and update this as the Red Hat legal policy around OpenShift subscriptions and all of that evolves, to help folks to understand how to work with it. So it's my quarterly cat herding exercise, as Christian knows so well, because we have to go out, we have to reach into all of those places inside of Red Hat and basically say, hey, is there any changes? Is there anything that you want to update in here? So mentions third-party apps again in a more general way, does it? Additional improved usage of the infrastructure node. Yeah, good eye. So yeah, there's a lot of stuff in here. And again, if it's confusing at all, if there's anything that you need help with, don't hesitate to reach out to your account team. You can reach out to Johnny and I, and we'll do our best to figure all that stuff out. And yes, our Hope 9 Trident is okay to run on the infra nodes.
Yeah, and Fuad, just to back up what Andrew's saying, right? Like if you're asking, somebody else is also asking, right? I mean, like, so don't hesitate to reach out to us and let us go dig in on it for you, because we want to make sure that everybody has all the information, so that way they can be successful.
Yep. And I will also say that I just recently learned that there is actually 2 subscription guides that are out there. What happened here? So one of them is, can't type. One of them is the old one. So there is actually 2 of them that are floating around out there. So the difference is, one of them, this one has the table of contents and stuff at the top, and you notice it says last updated February 8th. The other one will have the navigation on the right-hand side here, or left-hand side rather, my military left. And it has a last updated date of like last July or something like that. That one is not valid. So it has been superseded, of course, by this one, which has had at least 2, if not 3, pretty significant updates since then. So just keep an eye on that last updated date. The current release is February 8th. So we are trying to get that one taken down. We just have to find the right folks and get that done here inside of Red Hat, because I don't know who manages the web properties, strangely.
And before we move on, there was another question from G. Kumar about, it really says it's for us or Christian. Is there a preferred way of managing secrets? Sealed Secret is a community-based operator. Is that Red Hat's preferred way? I can just speak personally from our team. We're using HashiCorp Vault, as part of our secrets manager. Sealed Secret is really good. There's another group within Red Hat public sector that's using like SOPs for some of their secrets management and stuff like that. But I know from us on the pattern side that we're using Vault, and it seems to be pretty effective. I don't know if Andrew, if you have an opinion, or if Christian wants to chime in chat.
I have no opinion. Christian and y'all are far more knowledgeable in that area than I am.
And Christian's answer is the preferred way is the one that's supported. So yes, yeah, completely agree.
Sure you're not a product manager, Christian? It's a very product manager answer.
Yep, exactly. And there's a community and an enterprise version of Vault, and there's a lot of actual Vault support within Red Hat community of practice as well. They have the Vault operator, so there's a lot of good stuff going on with Vault.
Yep. All right. So please don't stop asking questions, but I'm going to go ahead and move on and talk about some MetalLB. So let's look at my cluster here. So if you saw it a few minutes ago, the cluster that I had deployed in preparation for today is running OpenShift 4.10.2. So we talked about it last week. Anybody can go and pull the pre-release bits. You can get those off of the mirror. You can also get those off of console.redhat.com/OpenShift. You just go to the deploy pre-release and you can get access to that. So one thing to notice for whoever was asking about when 4.10 will be released, you notice that we're out of the RC stage. However, notice that we're not going to GA with 4.10.0. More than likely, it won't be 4.10.2 either, as far as I know. That's just an artifact of how they do patching, how they do the versions, and all that other stuff. So it doesn't mean that it will go from in the upgrade branches, that it will go from fast to stable any faster or anything like that. That's entirely dependent on the post-release metrics and stuff that they have around update success. But just be aware that you can go and pull those bits. You can deploy it today. You can take a look at it. Some things are, I will say in my experience, not all of the operators work with the pre-GA release bits. And I say that because when I tried to deploy MetalLB and prepped for this, MetalLB operator failed. So it was trying to pull a image that was not available yet when I went to install this operator. So the result of that is I had to deploy using the upstream bits. So if we go to github.com/OpenShift and we search for MetalLB, MetalLB, we have this MetalLB operator here. Effectively, what I did was just pull this in. Right, I followed the documentation that's in here for how to go through and deploy it. And actually, I think I actually deployed the MetalLB one, not the OpenShift one. Yeah, it was this one. Post this into chat here. So just be aware that this is only temporary until it really does go GA. So for now, I had to deploy the upstream MetalLB operator, which is also, it's created and maintained by Red Hat. So it should behave exactly the same inside of here. I'm just one version ahead of what they were doing. So with the MetalLB operator deployed, it then added a number of custom resource definitions inside of here. Search for the MetalLB side of things here. We now have all of these different CRDs. We, of course, need to deploy MetalLB itself. So remember, an operator is what manages the deployment of operands or of an application. So deploying the MetalLB operator doesn't mean that MetalLB bits and pieces are deployed yet. It just means that we are ready to deploy those. So I created a MetalLB, and then inside of there, and it's a super simple, like there's nothing inside of here. You literally give it a name and click create. Here, MetalLBs, we'll do a create one. See, this is all I had to provide was what I wanted to name it. And then once the operator sees that, hey, you do want to deploy a MetalLB, it goes through and deploys everything for us. And you'll notice I'm in the MetalLB system project here. So if we come up here to pods, we have all of our pods running inside of here. So the other part of that, I clicked away, so now I have to do this again. You'll see that there's a couple of other custom resource definitions that exist. So there's address pool, there's BGP peer, and then there is BFD profile. So an address pool represents the addresses, right? The pool of IPs that we want to be able to use for our services when they're created. Right. So I gave it this set of addresses that I wanted it to use. And because this is, well, I'm using L3, I'm using BGP mode, we wanted to use protocol of BGP. So let's look at the documentation here. And what I want to do is MetalLB. And we'll click here. So this is the 4.9 documentation. So remember with 4.9, MetalLB layer 2 mode is supported. 4.10 layer 3 mode is added. So it'll be layer 2 and layer 3 mode with 4.10. So with layer 2 mode, where am I at here? When I create an address pool, you'll see that the protocol is layer 2. And then I can specify the range of IP addresses that I want it to create. So one thing that's important is let's talk about BGP for a moment. Again, I'll caveat this by saying that Andrew is not a networking engineer or a networking expert by any stretch of the imagination. So please, for any network savvy folks, forgive my layman's definition of how this works.
This is going to be amazing.
Yeah. If by hopefully not confusing, like my bar for success here is not more confusing than.
This is gonna be great. Let's do it.
So BGP, if you're familiar with, thanks Christian for the popcorn emoji. So BGP works off of the concept of autonomous systems, or AS, right? And we define between different entities, so between different routing groups, effectively, ASs, right? Separate identifiers for each one of those. And what they do is they publish routes. They publish how to get to a specific network based off of the networks that are, I'm going to use the term behind, but are accessible from inside of that autonomous system. So let's say that, my house is autonomous system 65,500 and Johnny's is, 65,501. And, inside of my network, my internal router can move traffic in between my networks. So let's say I'm using 192.168.0.0 slash, I don't know, 20. And then Johnny's using, 10.0.0.0 slash 20. So inside of my house, everything routes fine, right? My routers understand how to connect everything together. But if I want to get to Johnny's house, it needs to understand how do I route? How do I get from my autonomous system to his autonomous system? And what networks are behind his autonomous system? And so that's what BGP does. It communicates, hey, I'm over here. I have these routes. I have these networks that you can access by coming to me. There's a lot more complexity around things like how to do traversal. So let's say that Christian, who's in California, right? So let's say that Christian also wants to, join in our fun. And I have no direct connection to Christian's house and the networks at Christian's house. So I would have to traverse Johnny's autonomous system to get there. There's BGP magic that happens inside of there and how all of that is set up. It's way beyond, one, my understanding, and two, the scope of what I'm trying to show here. So the core of all of this is essentially BGP, much like RIP, much like OSPF, right? All the others. It allows us to create networks and then have the routing protocol basically advertise, hey, this is how you get to this network. This is how you get here, without each host having to understand how to do that, right? A specific host, my desktop, if I needed to get to Johnny's house, I just say, go to this IP address, and we rely on the networking devices to understand how to get there. Excuse me. So that's where I'm going to start this at. So with BGP, what I've done here is I'm using a set of IP addresses that do not exist in my network. Right? These are my network. I actually have a bunch of different networks in my lab / house here, but this 30.100 doesn't exist anywhere except right here, and I did that on purpose. Right. So I do have some 172.30.012 subnets. I have some 10.0 subnets. I have some 192.168 subnets. But this does not exist, and I have not defined it anywhere else except right here. So our protocol is BGP. So the next step that we need to do, let me go back so we can look at our resources. So I define an address pool. Hey, when you create a service of type load balancer, which is what MetalLB is going to service, no pun intended, it's going to assign it one of those IPs from that pool. When you create that IP address, or when you assign that IP address to that service, you need to advertise it to the BGP peer. So in this instance, I have one peer that's been created. And if we look at that, all I'm doing is saying, here is the upstream router. So this happens to be in my lab, it's the gateway router. And then here are the ASNs that I want you to use. So come on, get out of here, help. So ASN is Autonomous System Number. And I'm saying that the peer, the upstream, is 65512. And this instance inside of my cluster is 65514. So that's all the configuration I did here inside of OpenShift for MetalLB. So let's look at what happened upstream at my router. I'm doing this in a separate window so y'all don't have to watch me log in. And I think I can bring this in here and you should see it. All right. So here is my router, right? So I've got this BGP. You can see I'm using OpenSense. I installed the FRR plugin for my OpenSense. I enabled BGP and I set my autonomous system number inside of here. So that's what I did inside of my lab. And what we want to look at is what happens to our routing when we begin to deploy services inside of here. So if I click on routing, you can see that I already have one of my IP addresses. I already have a service that's created. So if I come back over here and go to networking, so I have this Hello Kubernetes service inside of here. And you see it has this external load balancer IP address of 100.10. And if I browse to that, it takes me to directly to my Hello Kubernetes service that's running inside of there. So what happens when I delete this service? So I'm actually going to do this from the CLI because it was deployed with Helm. So you hear me typing, I'm just doing a Helm uninstall. And what we should see here in just a moment, yep. So our application is now gone, right? No service. I come up here to pods. I've got my simple deployment, but I don't have my Hello Kubernetes running inside of here anymore. And if I come back over to my router and I refresh this, you notice that my routes have gone away. It no longer knows how to get to my particular nodes or that particular service. So let's create a new service. So I want pods. Nope, that's not what I wanted.
Yeah, Christian, you're right. Like BGP, it takes a while for it to propagate out because it's got to reach out to all the neighbors, and all the neighbors have to update their neighbors. It's just this cascading effect. It can take a long time.
Yeah, so in my lab, I'm fortunate it's only one router, so it only has to update itself. But yes, in an enterprise, it can take a little bit of time for it to propagate. So all I'm doing, you see I'm creating a new service, and I want to specify type of load balancer. Hope I'm remembering that correctly. So it's which means that MetalLB will be the one to service that service. So we'll hit create here. And you can see that that is exactly what happened, right? We now have this external load balancer. It reused the IP address. You can see it's the 100.10 IP address. And this time, if I browse to that IP address, I get my simple service. Simple service is just a thing that I created to get a JSON response for who is requesting this. You notice that this is coming from inside of the cluster. And then what's the server, what's the service that's servicing it? I keep saying servicing, which sounds like a weird phrase, right? So what you saw me do there is destroy one service that was using a MetalLB load balancer, and then create a new service that is using a MetalLB load balancer. And now if I come back over here, we'll see our 3 routes get created again. So let's talk a little bit about what we're seeing here. So first, you'll notice that it is creating a /32 for each one for the same IP to each one of my nodes in the cluster. So 160, 161, and 162. So that is BGP saying, I know how to get here. It's going to be one of these particular nodes. Let me see if I can stretch this. And you'll see that these columns, right? So valid, all 3 of them are valid, but it's going to prefer this particular link here, or this particular node first. So that can be changed. So when it does this, from what I understand, it will send traffic to that node first, and then it will use kube proxy, or the internal mechanism, to distribute traffic across the pods. You can also set it to local. So there's a policy. I don't have the docs page up, but there's a policy you can set where it will only send traffic to nodes. So these routes for this next hop that are hosting one of the pods that's a valid target for our service. So that's how it works in a nutshell, right? And I can't see chat, so I'm going to assume you're going to interrupt me at any point in time here, Johnny.
Yep, you're doing good.
Okay, so that's how it works in a nutshell. So there's a couple of other things that we may or may not want to know about what's happening inside of here. So first, let me deploy my other service again. Let's see. I'm just gonna deploy my the same Hello Kubernetes service that I had before, just so that we can see what that looks like when there are 2 of them. So let's click back over here. And if I come up here to deployments, we've got our Hello Kubernetes back. And if I click over here to services, we've got our Hello Kubernetes service back. You can see this time it was assigned the IP address of 100.11. And just like before, I browse to that, I get my Hello World application. If I refresh this, you'll notice here in the pod name, right, it's going to change the pod name periodically, and as well as the node name that it's running on. So it is load balancing across the pods that are running inside of there. And you can see each one gets its own IP address inside of here. So what are some other things that we can do with this? So let me bring up the MetalLB documentation as soon as I find the right tab here. And let me post that into Stream Chat here. So on our configuration, if we come down here to BGP, what I want to talk about here is our advertisement configuration. So the first thing that I want to say here is BGP is big and complex and a little bit scary if you're asking Andrew. The reason I say that is because BGP is like, it's what the internet runs on, like literally. If you were to query an internet router and look at its BGP routing table, it's like 250,000 entries and tens of megabytes in size on how to get places. And there are some very, very public instances where screwing up BGP routes has broken the internet, like literally broken the internet. Facebook has done it recently. I want to say Cloudflare has done it recently. There was a very public one back when some country black holed all of YouTube. Do you remember that? It was like they wanted to block YouTube in the country, and they updated the routing table and propagated it outward instead of inward, and they ended up creating a black hole for all YouTube traffic. So where I'm going with all of that is we should not be doing this in a vacuum, right? We have to work with our network architect, network administrator peers in order to make sure that this works successfully. So one of the things that, remember, each router has a finite set of resources. And one of the things that I want to talk about here is creating a /32. So remember over here, I've got a /32 for each node in my network that is a speaker for MetalLB. If I create 100 routes, or 100 services, or 1,000 services in my cluster, I'm going to have 3 /32s for each one of those. So it's entirely possible that you could basically extinguish the resources on your routers in an enterprise situation. And of course, that would be bad. So to work around this, MetalLB has this advertisement configuration. And effectively what you can do is you can set an aggregation length. So what that means is that instead of creating a /32, where'd my window go here? Instead of creating a /32 for each one of these, so if I refresh this now, there should be 6, right? One for 11, one for 10. It will create a /24 for all of them. So there'll be one /24 entry into each one of the nodes that is acting as a speaker for MetalLB. I am realizing now that I may have skipped what a speaker is. Let's go back to our pods and let's look at the MetalLB system namespace. So if we look inside of here, so this is the MetalLB deployment. So you see I've got my operator controller. So when I went and deployed the operator, this is what it deploys. This is what manages the custom resource definitions, etc. I've got the controller, which is what actually does things, like it's the one that is talking to each one of the speakers to request that they do configuration. So if we look at the logs for our controller, we can see here it's allocating IPs, and then it'll reach out, updated service object, right? It'll reach out and it'll talk to each one of our speakers. And the speakers are what actually handle that traffic. So you can see here it's creating ARP responder, NDPR, right? All of the things that it does. Yes, resume stream. Service announced on the IPs for our 100.10 and 100.11 load balancers, right? The speakers are the pods deployed to each node that are actually managing that traffic. And if I were to look at the expanded view, there would be one of these on each node. It's a daemon set speaker. So that's why the speakers are important. And you can basically, for every speaker or for every node that is hosting a speaker, you want to have, it will create a entry over here in our routing table log. So you can use node selectors to limit that to specific nodes, which you would definitely want to do in larger clusters to prevent these routes from just getting totally out of control. Just be aware that that is, right, those are effectively ingress points for your cluster, right? So you would treat them just like you do a infranode that is running an ingress controller, including having the ability, right, it is going to be sharing network throughput and all that other stuff with the application that's running that, as well as anything else that's running on there. So you may not want to have it on the same node as an ingress controller. Daemon set or daemon set. Yeah, I switch back and forth, Christian. Remember, I use all the words incorrectly all the time, just to make sure that everybody disagrees with me at some point. Right, there's kube control, kube cuddle, kube CTL. Yeah,
I embrace hostility.
It's a matter of opinion, right? So, yeah, 192. So Kaiser. So yes, my nodes are on 192.168.14. So if we come down here to compute nodes, is it going to show me on here? Maybe not. I so rarely look at this interface. Yeah, there we go. Internal IP 14.162. And then the other two are 160 and 161. So that's BGP, MetalLB, BGP mode in a nutshell, right? Again, work closely with your networking peers. They should be able to feed us all of this information, right? They're going to tell us specifically which ASN we need to use. And unless the peer ASN and a local ASN are inverted and match on the other side, it's not going to successfully instantiate the BGP session, and it's not going to work. If they want to do aggregation, then we would want to work with them to determine what is the appropriate subnetting to use for that aggregation. They should also assign us the IP pool that is coming from that. So the communities are an interesting thing. So the communities, and there are 3 common communities. There's no advertise, no, gosh, what are they now? Anyways, they control what we are requesting the upstream, the next hop router do with any routes that we advertise. So no advertise would mean, hey, don't advertise these externally beyond you. So it wouldn't work for any traffic that has to traverse to a different router or to a different AS. You can advertise externally, for example, and then it'll be broadcast across everywhere in order to get there. Other thing that I want to talk about here is, here, limiting peers to certain nodes. This is what I was talking about with the node selectors. So the other thing that I wanted to talk about quickly is BFD. So effectively, BFD, as it says here, quicker path failure detection than BGP alone provides. So again, work with your network peers in order to determine what the correct settings for the BFD profile is. The goal being, if that router fails for whatever reason, whatever the next hop, the upstream router is, how do we handle that and how do we recover from that, right? So that it can recreate or repropagate out those particular routes in order to regain access. So I'll pause there and all that other stuff. And what was I going to show? I don't remember. So the last thing that I wanted to talk about on this is just a quick highlight that with OpenShift 4.10, the external DNS operator is in tech preview and it only works with hyperscalers. So external DNS operator. So The external DNS operator is in tech preview with 4.10. What this will do eventually, because the upstream external DNS operator has alpha level support for updating many other types of DNS servers, eventually we'll be able to create annotations on our, let me see if I can find an example here. We'll be able to create annotations on our services, blah, blah. Sorry for all the scrolling, folks. Test. So we'll be able to create annotations, and it's not going to show me in here, that say, I not only want to publish using MetalLB or whatever my external load balancer is, this service so that it's externally accessible directly, I also want to create a DNS entry for it so that you can now, basically publish something outside of the OpenShift ingress controller mechanism inside of there. But again, with 4.10, it's only tech preview. It only works on Amazon, Azure, and Google. It doesn't work internally. But the upstream operator or the upstream functionality. So here's the Kubernetes SIG external DNS. So if we look at this guy, you see there's a whole bunch of different DNS providers supported. If you're using Bind like I am, RFC 2136 would be, I don't want to look at the actual RFC, thank you. No, the RFC would be 2136 would be how we want to update that. And then if I click down here on the actual documentation link, it tells us precisely how to configure that. Here's an example, right? So annotations, external DNS, blah, 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 service.example.org. So what happened is when I publish that, it would then create a DNS entry to point to whatever, IP address is assigned to it.
That's going to be such an awesome feature when it releases. I mean, I know that's been like a long awaited thing. So like that's going to be awesome.
Yeah. I can see it either way, right? Good or bad. Ingress, OpenShift ingress controller, the routes mechanism adds a lot of value, in my opinion, most especially like certificates and all of that other stuff. And, you don't have to manage those yourself. Everything old is new again. Yes. My children wearing, 1990s clothing. I distinctly remember the 90s, and it's funny. What is QWERTY123? It's a very terrible password is what that is. I don't know where that came from.
We kind of, there's a small tangent about secure passwords. And so we're all putting our most secure, unsecure password.
Yeah. So, all right. I will take a brief tangent because somebody had asked about what my lab looks like. So I'll actually take a brief tangent to look at that. And I say that, so let me log into vCenter here. Because my lab is constantly changing. Although right now it seems like it's been the most stable that it has been in a long time. So my lab consists of a grand total of 2 nodes inside of here, right? Both of them are actually desktops. I chose to use regular off-the-shelf desktops because they were very, very, 1, affordable, and 2, customizable, which is what I've done kind of to an extreme almost. I would love to simplify. I just haven't found a way that I can still do all of the things that I want to do. And upgrade to something like, I think Christian has was an R720 or something, or an R730 in his home lab. I just haven't been able to get there. So for me, I have a couple of things inside of my lab. So the first one is a TrueNAS, formerly FreeNAS virtual machine that has all of my storage attached to it. So in my case, I use M.2 SSDs because they're small and I can easily cram a bunch of them into the case. And from there, I provide all of my shared storage. So if we look at my storage over here, I have like an iSCSI LUN that comes off of that. I have an NFS export that comes off of that. So that virtual machine is the only one that uses local storage on this host. So when I go and turn on my lab, I turn on the host that has this virtual machine attached to it, and then it has PCI pass-through for all of those storage devices, and then creates the shared storage pool that then has everything else on it. From there, I have a helper. So it originated with Christian's helper node, but I have since taken it and I have expanded it. So Christian and the automation that he created creates a helper node instance with all the services, DHCP, DNS, load balancer, all that other stuff for one cluster. I have mine configured for like 10 different clusters that I can stand up in different configurations in different ways and all that other stuff. So same core services, right? Bind, HA proxy. I don't know why HA proxy just escaped my mind. The ISC DHCP server, right? All that other stuff inside of there. I just, customize the configuration. And then aside from that, you'll see things like I use this Bastion VM to mock or mimic a disconnected environment when I need that. vCenter. Interestingly, I don't turn on vCenter very often unless I'm doing something like a VMware API installation or something like that. So you'll notice if you were quick-eyed, I have a 3-node compact cluster, but I actually deployed it using the API method. So that's completely unsupported, right? You can't do a platform integrated compact cluster, but it works and it helped to illustrate my purpose without having to jump through a bunch of hoops. So I turn on vCenter for things like that, but most of the time I just connect directly to my ESX hosts and turn things on. So this VM I was using the other day for what was I using it for? That was my the one that we used for the OC mirror, the local mirror and all that other stuff. And this is my usual demo cluster. This is the one that I use for most things. So this is a non-integrated cluster that's deployed onto vSphere. And then this one I recreate on a regular basis. It's non-integrated specifically so that I can, I don't have to worry about the infrastructure integrations and stuff like that. But I also do things like nested virtualization in here. So if I want to, test with OpenShift virtualization or something like that, I can use that. So the only fanciness here, if you if you can see it, I have this DV trunk. So all I did was create if we come over here to the networking, I created a VLAN trunk port on my switch. You'll notice that there's 2 of these. For whatever reason, I was having issues at one point with the standard switch trunk port. So I created a DV switch trunk port, and that works great. I don't know what the difference is, but it fixed my problem. And that's what I use when I want to do things like create VLANs that get passed through, into the bigger network. So the other side of that is, if you were a quick guide here, you'll see I've got a couple of different networks that I use for all of my lab stuff. So one is the work stuff. This is what my work desktop sit on. It's kind of the management interface for most things. The other one is the lab. This one is isolated. It's what I consider the disconnected network. So when I want to deploy things and test it that way. So yeah, my lab is pretty simple, all in all. I'm happy to answer any questions about it. Folks can send me messages on social media or send me an email if you have any questions about how I set it up. There are some limitations, right? My 2 hosts, each one only has 64 gigs of memory right now. So I can only deploy 1 or maybe 2 small OpenShift clusters, depending on what I'm doing inside of there. Yeah. Let me know if there's any questions on that. And then, so the last thing that I wanted to talk about today is NMState. So let me find my cluster here again. So the NMState operator is, as the name implies, it is a stateful configuration engine for Network Manager. So effectively, anything that you can do via NMCLI or NM2E, you can do through NMState. What it's doing is just defining that using YAML. So let's do, and I can't type. If I do a search here for NMState, I don't want New Mexico. I want NMState. So if I do a search for that, you can see that it comes up and talks about the upstream project for NMState. And this is something that Red Hat has been using for a while. So if you're familiar with Red Hat virtualization, so Red Hat Virtualization Manager 4.4 uses NMState to apply network configuration to the hosts. Right? So it uses it for all hosts, and it's also the thing that works when you do in 4.4. You can like copy a host network configuration and apply it to other hosts. It's all NMState driven. So here we can see it's JSON output, but it also works with YAML. And there's a bunch of different examples of how to do things like I want to create a bond. So here's YAML. And all we're doing is defining in YAML or JSON exactly the same thing that we would be doing on NMCLI, right? So I want to create a bond that is in a state of up. I want to assign it this IPv4 address. For the bond, I want it to use a balance RR mode, and I want these two interfaces to be members of that bond. It's literally all it is, right? If I want to create a bridge interface, right? So I want to create an OVS bridge. I want it to be on top of this particular, network adapter. And you can define, a bond to be a part of that as well. And you can combine these, right? So I don't have to have these as separate, files or separate implementations. I can combine all these into one, and effectively, because it's a state engine, it will ensure that it matches that particular configuration. Also, that one thing that configures, folks, is if you want to unconfigure something, you don't just remove the configuration. You have to set it to basically present equals false is how you remove things. So how does all of this fit in with OpenShift? So let me find a documentation. I thought I had a documentation page up. So NMState has been a part of OpenShift since 4.6, which was when OpenShift virtualization was released. And since 4.6, NMState has been fully supported when used with OpenShift virtualization. So we want to go to node networking here. And down here, we have these, observed node networking state, right? And updating node network configuration. So all of this has been available with, again, OpenShift deployed directly to physical servers when used with OpenShift virtualization since 4.6. With 4.10, we're now expanding that to be generally available and fully supported with all bare metal deployments, right? So that means that I can go in and I can apply day 2 that networking configuration. So let's come down here and find an example. I apply that networking configuration to my cluster as I see fit. So let's look at what this, how this looks and works in practice. And I'm going to hope that this works because I literally just before the stream deployed the operator and I haven't actually tested anything yet. So we'll see what happens, right? So if I search my CRDs here for NMState, you'll see that I get these NMState set of CRDs. So the node network state represents the current status of the network configuration of our node. A node network configuration policy, an NCP, represents how we want to configure the network for a particular node. So if we jump back over to our documentation example here, this is a node network configuration policy. And then our node network configuration enactment is on a per node basis, the status of the node network configuration policy being applied. So I hope that made sense. Node network state is the current state. Configuration policy is what we want to apply. The configuration enactment is the status of the configuration policy on a per node basis. So let's look at our node network state. And you'll notice that I have an instance of this for each one of the nodes inside of my cluster. So I'm going to select one of these guys and look at the YAML. And down here in the status, we have our current state. And it walks through and shows us everything that we know about the network, right? So effectively, if you were to use NMCLI and kind of show the tree of configuration for our network, this is all the information that we would find out, right? So we have this, where is it? So here is BR0, right, which is an OVS interface. It's currently down. I have 2 IP addresses. I'm not sure why that one has a 32. Again, I just just tested this, so who knows what we're going to find out. And then, so here's our MTU. Here's the network adapter that it's using, right? It is VMware, so ENS 192. We can see our speeds, right? Down here, we've got another IPv4 address. This one is running on ENS 224, right? So on and so forth. I can keep scrolling down through here. Here is the OVS. So this is going to be the SDN, right? Down here, I've got route config. So it's a breakdown of what is the current configuration of my nodes, of my host. So you'll notice here that I have 2 network adapters on my hosts. So let's come over here. So I've got 2 network adapters, one connected to each one of these. So you'll notice that that second adapter also pulled an IP address. That's because it has a native VLAN on it. So that would be this interface here, ENS 224. So let's say that I want to create a bridge on that interface, and I want to remove this IP address. So let's go back to our CRD list. And I want to create a node network configuration policy. So notice that first I have no instances here. And I need to find the instance that I want to use. So I'm digging in my notes here to find the instance that I want, or the example that I'm going to use. All right. So let's paste that in here. So I have a node network configuration policy. We'll give it an arbitrary name. Like anything else in Kubernetes, I can use a node selector. So I want it to apply to anything that has a worker label associated with it or a worker tag associated with it. And then what we're saying here is I want to create a new interface named BR1 that is a Linux bridge. I don't want it to have an IPv4 address, and I want it to use port ENS 224. So let's say that I wanted to keep the IP address that's assigned there. I can leave this IPv4. I can basically omit it. And actually, because we're creating a new interface, I think it would inherit the default, which is going to be DHCP. Or I can expressly configure DHCP or a static IP address on it, and it will apply that. But because it's set to enabled false, it will remove that IP address and it won't reconfigure it. So one thing to note, if you're using OpenShift SDN, you can modify the first interface, right? The one that is the quote unquote primary interface where things like the SDN is using. If you're using OVN Kubernetes, I think it's still possible, but it's a little more complex. And it's basically you have to set OVN Kubernetes to use the local gateway detection mode, if I remember correctly. There's a BZ out there that has like the exact details. It's something that was changed either in 4.9 or 4.10. I'll have to find it and we can put it in the blog post. So the end result of all of this is that hopefully, ideally, when we're done here, what we're going to see is my nodes be configured with a new bridge named BR1 that will have our network adapter attached to it. So we'll hit create here. And now I can go back to my custom resource definitions, search for NMState, and look for my configuration enactment. And you see that I now have a configuration enactment for each one of my nodes. So you see here's the node name, master-0, and then worker-br1-ENS224, which is the name of my NNCP that I just created. So we'll click on this guy, and we can see that it has successfully configured, supposedly. Right. So here's our status conditions where it's saying it's successfully configured. If I go back to my custom resource definitions and find my NNCP, what we should see is that this one is also set to successfully configured with 3 out of 3 nodes. So how do we verify that? How do we check that? So one thing that we can do here is look at our node network state again. So I'm going to go back to the same node. And now if we scroll down, we should see a new bridge let's see, where's it at here? So here's the start of a new entry. So we see it's a bridge, and we have port 224 assigned to it in trunk mode, but no IP address assigned to it. There, BR1. All right, no IP address assigned to it. So that IP was removed from the host. But we still have our other IP address, the 162 that's down here. So just like that, we added a new configuration. We reconfigured the network on our host. If I look at host 2, we should see the exact same thing. Here's our bridge, port 224, ENS 224, name of BR1. So that's how we can apply day 2 network configuration to our hosts. Now with 4.10 and bare metal deployments in particular, this same functionality can be applied to basically during installation. So I don't know if I have a link to it here or not. See if I can find one in the pre-release documentation. So if I find installing, and I want to install to bare metal and network customizations, and generic search. Anyway, so at some point the documentation will be updated, and effectively in this networking section, you'll be able to add NMState definitions. So this is particularly useful when you want to do things like I'm installing to a bare metal host, and that bare metal host has, I need to configure a bond and a VLAN interface that it's going to use for that primary interface, or I need to, whatever that happens to be as we go through. So I don't see it in the docs here, which means that there's probably a PR out there for it somewhere. But yeah, we'll I'll highlight that once the docs go live and once we have everything inside of here of how to do that. Hopefully, I'll be able to put that into the blog post for this week. So I'll pause there, Johnny. You've been awful quiet. I haven't looked at chat in a while. So is there anything that I should know?
Yeah. So there's one question. Yeah. So I was answering some questions from. I lost it, but. Anyways, it was about SRIOV and like a Linux bridge or OVS bridge. So OVS bridge is software defined, bridging in a Linux network world. So, or in a Linux bridge, it's essentially just like if you look at it, it's like a switch port, right? I mean, it just says, hey, I need to get from here to here. So it's a layer 2 interaction where SRIOV is like a pass-through networking. So if I understand that correctly, it's like a full-on, it's like a legit, PCI to VM or to machine, and it bypasses any SDN type stuff. So that was one of the conversations going on. And then Kaiser asked if you could expand more on fully supported when used with OpenShift virtualization. Can I use NMState Operator in a supported way for configuring my primary interface just by installing C and V?
Yes. As far as I know, yes. So I don't know that anybody, whoever on the support side goes through and like double checks, like, have you deployed any VMs to make sure that it's there before they do that. So I would say yes, if you deploy OpenShift virtualization, it will automatically deploy the NMState operator as a part of that, and then you'll be able to do that configuration stuff. It's deploying NMState operator without OpenShift virtualization that historically has not been supported.
Gotcha. And then Alan was just asking, essentially, like, well, so how do you do PCI pass through of a network to a VM and CNV?
Yeah. So if we go to, I think it's down here. IO PCI pass through is what you want. So effectively, you're doing PCI pass through of the device, and SRIOV is supported with OpenShift virtualization.
Yep, and our Hope 9 shared a link to the SRIOV operator. So just something to check out as well.
Yeah, I think it's slightly different with a pod using an SRIV adapter versus a virtual machine, but I'm not entirely sure. I will fully admit that SRIV is outside of my realm of.
Oh my god, dude, same.
I don't think it matters if it's InfiniBand or not, Alan. But again, I would have to double check on that. It's so long as it's supported by CoreOS, which means so long as it's supported by RHEL, then in theory it will work.
Yeah, Alan, and if you have more details that you want to provide, feel free to email us, and we'll get the answer for you. Right? I mean, just shoot us an email with like the architecture that you're looking at, and we'll see if we can get you an answer.
Yeah. Okay. Any other thoughts? Anything to add, Johnny?
No, man, you did really good today. I was expecting total glory, but you killed it. So
it's funny. I was telling Johnny before we started here that normally I spend the morning before the stream kind of prepping and making sure that everything is staged and I have the flow in my head. And I lost like an hour and a half this morning to a phone call with that was unexpected. So I didn't have as much time to prep. Kind of funny.
Yep, you did good, kid. You did real good.
I'm gonna, just because we're already way over, so what's another minute or two? I want to see what happens if I go in and I try and remove this thing. So let's go in here, and we want to go to, what is it? It is status equals false, maybe. Removing an interface, state absent. So if I take this guy, and I think all I need to do is to set the right indentation. I leave everything else the same and just set state as absent.
Yeah, you're at the same level as the other state. So you see how you have like your state up?
Yep. There's a conflict. I think I did. Yep. I spelled it SCENT, like a smell. All right. So now if we hit save here, what we should see is this guy go back into a progressing status. There, 2 out of 3 nodes finished. And there it's been applied. So now if I go back to, by the way, this is much easier from the CLI where you can just do an OC get NNS. If I go back to our instance, YAML, and scroll down through here. So here's our list of interfaces. So here's the first one, which is ENS 192. Here's the second one. You can see that ENS 224 is not doing anything, right? So there's no configuration on ENS 224 anymore. Right, there's our loopback interface. So here is our OVS for the SDN, both of them. But you'll notice that my bridge is no longer there. And now I can simply go back, and now that it has been unconfigured, if I want to, I can delete this NNCP. So that way it doesn't have to, right? It's not constantly trying to apply that. So yeah, that's how to configure and then unconfigure networking using NMState. Hopefully it's helpful. We'll be working on for Red Hat folks, we'll be working on some collateral in a technical deep dive presentation that dives into some of this stuff as well. But yeah, that's all I got.
This is good. I think it's really helpful. I mean, honestly, like there's a lot of day 2 stuff that I think people are going to get out of this. So it's really good.
Yeah, we get a lot of questions, right? I know you see them as well of, hey, I want to add a second adapter for a storage network or for something like that. How do I configure that? And, a lot of folks assume that the answer is use machine config. And machine config works in some scenarios, mostly where DHCP is available. But if you want to do static IP configuration, you would effectively have to have a machine config pool per node to set that static config. So NMState is one way that we can, basically work around that, both at install time as well as day 2. So
yeah, it's gonna be that's a cool tool, and then the MetalLB stuff is pretty awesome. So I'm looking forward to messing around with that.
yeah, I'm looking forward to getting more familiar with it as well. Like I said, I scratched the surface of BGP as I was, going through and implementing this inside of my lab, and just all the stuff that is possible with it. There's a whole unexplored avenue of things of like how it makes a determination of which interface to send it to. I will note that, I don't understand. I don't know what algorithm it uses to determine, last time I sent the traffic out this, to this IP address, next time I'm going to send it to this one, next time I'm going to send it to this one. Whereas with a quote unquote real load balancer, there's a lot of policies you can put in place around that, right? Least number of sessions, least amount of traffic, least recently used, straight vanilla round robin. Gosh, excuse me. So yeah, it's one of those, there's more to learn. I am curious about, and I would love if anybody is a networking, a BGP expert, like what's the impact to the router on that? If I'm using a MetalLB BGP load balancer and it's pushing, tens of gigabits of traffic, is there an impact to the router as it's having to make those decisions with, potentially thousands of sessions? I don't know.
Yeah, good call.
So, okay. Well, I'll quit rambling. We're 37 minutes past our normal stopping point. So thank you everybody who has joined us today. We'll definitely follow up on a blog post with this one. We'll link to all of the relevant places inside of the stream here, so that way you can find the information that you need. If you have any questions, if there's anything that we missed, that we didn't answer, anything that comes to mind as you're watching this after we're live, please don't hesitate to reach out with any of those questions at any time. So as is on the screen now, you can reach me on social media at Practical Andrew on Twitter or on Reddit. You can also send me an email at any point in time, andrew.sullivan@redhat.com. So, and Johnny is JRockTX1 on Twitter, Johnny with no H, JONNY at redhat.com. I don't remember what your Reddit username is.
Yeah, it's something stupid.
Yeah,
so.
look for this. Look for the live stream posts on the OpenShift subreddit, right? But yeah, we are more than happy to help with any of those questions, anything that comes up. So thank you, everybody. Reminder, next week we will be talking about service mesh. 2 weeks we'll be talking about microshift. Christian's been doing a lot of really cool stuff with microshift. He and I have been chatting on the side. He got OLM deployed to microshift, which I thought was really cool.
Oh man, nice.
Yeah. So we'll have a great conversation with those guys when they're on in 2 weeks. And with all that being said, thank you so much, everyone. And Johnny, last words.
Yep. Thank you. Great episode, Andrew. Even though, you thought you winged it, you did awesome. So, good work. And Stephanie, as always, thank you for everything.
All right. See you next week.
Yep. See you guys.